Hey, what's going on YouTube? What's up? I think that we are live. Welcome back to my practice stream. My name is John. If this is your first time here, welcome. This is a nice little community of live practice of math. I'm practicing linear algebra. I'm also practicing some high school math and some graduate level math, but today is college math. We are at linear algebra, and we are going to be talking about my favorite subject, which is vector spaces. Vector spaces is the beginning, I think, of abstract algebra, and it's the beginning of abstract, to me, pure math and like beautiful math, like argument-based math, like theoretical math that requires proofs. You get to write the word proof all the time, and that's just really nice. It's really, really nice. So, yeah, we're going to be talking vector spaces. Last time that we streamed vector spaces, we also had a nice little cameo by this guy, Sheldon Axler, but then we didn't get as much done. We went a little deeper, we worked an Axler problem, but we just didn't get as far as we usually do. And this book is meant for a second course in linear algebra. Someday, we will upgrade the series from linear algebra 1 to linear algebra 2, but not today, my friend. We are still in semester 1 linear algebra. And so we're going to put Axler away. And although it would probably get a lot more clicks, I would probably get a lot more attention out here on social media if I work Sheldon Axler. I want to work Fraleigh. This book is wonderful. It's lovely. I'm sure people are going to ask me about it during the stream, and I will, geek out about it. All right, so let's get into it. Oh, that didn't work. All right, give me 1 second. Why didn't that work? Weird. Air server crashed. Something crashed. Okay, well, it's nice to meet you. If you don't know my background, I am a former mathematics major. I studied pure math. I trained to become a research mathematician. I decided not to go to graduate school, and I decided to go make some money, dude. And I worked as an iOS software engineer for 10 years in FANG companies. I worked at Apple, then I worked at Lyft, then I worked at Google, and then AI took my job, and now I don't really feel like getting a new tech job because coding with AI is super boring, dude. I like thinking hard thoughts, solving hard problems with my brain, not somebody else's brain. And now I want to return back to math and become an awesome high school math teacher. That is my goal. So I'm here practicing, I'm relearning mathematics, but kind of more importantly to me, I'm practicing how to teach to like a small group of students, or at least peers. We've got a lot of like graduate students in the chat, but we also have high schoolers from around the world, like who have never learned linear algebra before. It's a nice little community. So if anybody's watching the VOD, here's your chance. Like and subscribe, leave a comment below, ring the bell, and then you can get notifications when I'm live. I hope to see you in the chat sometime. It's much more fun. All right, let's go. So quirky little twist is that all this guitar music we're listening to is also, it's me. I'm a guitarist as well. All right, section 3.1, vector spaces, in exercise 12. Determine whether this set is closed under the usual operations of addition and scalar multiplication, and is therefore, and then is it also a real vector space? So we have 3 different parts that we need to show. Part A, we have closure under vector addition, or under addition. Then later we will do part B, closure under scalar multiplication. Can we scale one of these points in a vector space? Can we scale the vector? And then thirdly, is it a vector space? So this is organized in a way that says first, we have to have an addition operation on the vector space. Then on the set V. In fact, I'm going to try to be somewhat strict. You don't have to have your set be a vector space in order to have addition defined. Addition is, what is addition? It takes a pair of things and then somehow combines those two into a third one. So addition is a function of a pair of things, of numbers. I will speak more broadly of numbers, but of things, of points or something, so that we get a new element which we will call a plus b. But this is one number. This is one new point in the set S, which is and then same thing for similar but different for scalar multiplication. We need to have this triple, where the multiplication operation is going to take a scaling factor, k, and it's going to take a vector or a point in our set. So this might seem a little strange, but I'm writing this function. In Swift, we would use backticks for like Unicode characters, and maybe that can help see that this is like the name of a function. The function name is the dot. And it is going to operate on, I'm going to go k cross s to s. So, and why don't we swap these two so that it's k operating on a set S. Another way to write this would be ks, which is the set of all ks such that k is in k, and the point S is in your set S. These are different types. The type of k is different than the type of S. So this is called, I'm blanking on the name of, like, operation on the action of k on S or something like that. But k is a field. Well, in order for it to be a vector space, we need k to be a field. Just to be defined to have scalar multiplication, under scalar multiplication, to be closed under scalar multiplication, k doesn't actually need to be a field, I don't think. I don't think k needs to be a field, so I'm actually going to try to make this a little more generic. AS. It's some multiplication operation It's any function that takes a pair of elements from the set A and the set S and then produces a new element which we call AS. I'm going to adopt this notation from Swift. That is like the backtick symbols, but over here I use quotation marks. Maybe we can just use quotation marks. Either way. But this is one number or one element of the set S. We just write it as AS for now. So closure under addition, if I add two things, then the addition is still in the same set. If I multiply a thing by a scalar, then we stay within the set. It stays closed. Like if I multiply the set by scalars, then it stays within the set. A way to write this would be that multiplication by elements A stays within the set S. And over here, can we write, is it fair to say, something like S plus S is contained in S? I think that makes sense as well. This is a way to, I've never even tried writing closure under addition and closure under multiplication. Right now I'm deliberately trying to use more vague symbols, more vague terms or labels for these sets, because you don't need the set to be a field in order to have closure under multiplication. And we don't need the set to be vectors to have this type of property. This is like an algebraic property. Parts A, B, and C are all separate, independent ideas. Then finally, we need a vector space, including various different axioms. We have 8 axioms for a vector space. Now I will write, we usually write a vector space over a field with addition and multiplication. There's probably another way to write that, but we need our set S to be a set of vectors, and we need our set of scalars to be a field. So I want to say, I need to define what I mean by that, but this is a field, and now our set S is a set of vectors. Cool. All right, let's plan out the game plan again, because I've already written out the goals of parts A and B. Our multiplication is given for us in this problem, and our addition is defined for us in this problem. Let me just write down the goals for vector space to complete this idea, because I started here, but I'm missing the next steps, like the goals. I remember that there are 8 in total. there is, what's the best? There's an identity element of addition. There is a identity of scalar multiplication. There is associativity and associativity. There is, what else? Commutativity. Oh wait, no. Let's go inverses and commutativity. There is then our combination axioms. Distribution 1, distribution 2. What's up, Leo? Dude, you just pop in. You just pop in for the shout out and then take off immediately. Shout outs to Leo Lectures, dude. Everybody, if you're watching this stream, you're probably gonna like his stream too. When's the next stream, man? I'm gonna go ahead and just start calling you a streamer because you should be. Peer pressure. I double dog dare you to do it live, dude. Typically, the vector space T poses over the field to show dominance. Okay, lol. What is T? I've never seen T being used. I like it. Okay, so we got identity as inverses, identity as dist 1 and dist 2. Now we have our goals. All I read so far is just the frickin' italics part, but I know what my strategy is already. My strategy is to show those various different goals that we talked about. Now, what the heck is my iPad froze? It's plugged in, so it's not out of batteries. I don't know what happened. What's up, Leo? Good to see you, dude. Okay. Set of all 3x3 matrices of the form this. Neat. Now, is X an actual... Are these all the same? Or are those just placeholders? Because it doesn't look like ASCII X. It looks like a cross Unicode symbol. Because we get different answers, I think. They don't look like... Oh, it says where X may be any scalar. I see. Okay. But then still... Are they all fixed? Or is there one X that they all have to equal? Because if... Well, I guess it... Wait, actually, yeah, maybe it... Doesn't it still... Yeah, even if they are all equal, maybe we do still get a vector space. Neat! Okay, neat. Maybe we do. I thought for a second that we wouldn't, but let's see. Let's target this first goal right now. We have closure under addition. So let A be in S and B be in S. Then A is some A, 0, A. I'm going to assume that they actually mean that they're equal. For now. Wait, no, A is not in capital A. A is in, are we talking about a real, yeah. In this book, the field is always the real numbers for most of the chapters. And similarly, B is some other. B, lowercase b, 0, lowercase b, Bob, oboe, and Bob. Let's add another page here. Hello, took my first steps toward calculus. Yeah, man. Yeah, you did. You've been watching my streams, though, so I think you've already taken your first steps by watching my streams, bro. Did you see my pre-calculus stream the other day? 'Cause that's quite literally a first steps toward calculus, right? Pre-calculus. Dude, we are at the very beginning of calculus in my stream. So if you want to try to learn calculus, it would be awesome if you want to try to learn it with us. We're at the baby steps. Yeah, you've seen many calculus streams of yours. Well, then you've already taken your first steps toward calculus, dude. You already did. You didn't even realize it. But what do you mean by, you just said that you took your first steps, but you've already done that. What's up, man? Good to see you. Let's get chat up on screen and get some social proof. Look at that. I have friends hanging out with me, studying math. Look at that. Look at that. How does this get messed up so often? Apparently I need to migrate away from Stream Elements. That company is like shutting down. I didn't know that. Ah, you've studied limits and derivatives. Nice, man, nice. Well, limits, spend more time on limits. If you're just taking your first steps, don't go to derivatives. I spend all 3 streams. This time around, I spent all 3 streams on limits. They're that important. They are that important. Trig functions aren't necessarily part of calculus, no. Trig is part of trigonometry, pre-calculus, algebra, but you can study trig functions with calculus, sure. But they're separate. You can do calculus, you can learn all of calculus without trig, I think, if you want. But just keep hitting those limits. And don't skip the rigorous definition of limits. Man, that's what we did. Yep. Okay, cool, man. Cool. Well, good to see you. Okay, so we got AOA, OAO, AOA, Bob, oboe, and Bob. So if I add these 2 matrices together, A plus B is A plus B, 0 plus 0, 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 and A plus B there. Which now I could call these C0C, 0C0, and C0C. This is now in the set of matrices that we were talking about. Let me make my to-do list for today. Nice. Yeah. Awesome. So we do have closure under addition. We do have the same structure when you add any 2 matrices of this form. Now, what about closure under scalar multiplication? I think we do as well, actually. Well, actually, yes, we do. And the problem said that we have the usual addition and scalar multiplication, I believe. Yeah, the usual operations of addition and scalar multiplication. So let k be in the real numbers or any field, but let k be in the real numbers and let A be in the set of matrices of that form. Then Ka is k times A0A, 0A, 0, A0A for some A, for some real number A. Then this is Ka, 0, Ka, 0, Ka, 0, Ka, 0, Ka, which is now right? So Ka is also in the set, and then therefore our action of the real numbers on this set is still contained in the set. Specifically, the scalars are the real numbers. So every a scaling of any of these matrices is another matrix of that form. Okay. Now, final goal for us today on this problem. It's this problem, this bit. We have this third goal, a vector space. Do we have an identity element? Yes, most of these we inherit. We inherit all of these, honestly, from the usual operations of matrix addition and scalar multiplication on matrices. Yeah. All axioms of a vector space are inherited from the parent vector space, which is the set of all 3x3 real valued matrices. Hello, I'm a lock in now. Yeah, me too, man. I think that's fine to say. Like, you can convince yourself that that's true, but this problem is talking about a different, like a vector space is the set of all of these 3x3 matrices. Does this form a vector space under the usual operations of addition and scalar multiplication? The book hasn't yet defined subspaces, but this is the idea of a subspace. In section 2 or section 3, we see that if a if a subset W is a subset of a vector space. In our problem, we have all of these 3x3 matrices, which is a subset of the set of all 3x3 real valued matrices, right? It's a subspace if and only if it's closed under addition and multiplication. So we showed this. We showed that it was closed under addition and multiplication. So then therefore our subset of these XOX matrices is a subspace of all 3x3 real valued matrices. Okay? Pinch your screen. I'm doing it all the time, dude. In and out like that. I hope you enjoyed it. Hey, what's up, Ta? How's it going? Hey, sleep well. Sleep well, Ta. It's good to see you, bro. Kartik Kaushal, 2006. Dude, were you born in 2006? Bro, somebody who's born in 2006 is 20. What? Wait, what? I just realized that today, just now. Bro, you were probably born in 2006, weren't you? No. No. That's no. No. Wait, what? I love it, but I hate it. How's it going? Alright, so welcome to my practice stream, everybody. We completed this problem. I think we're good on this one. So, I know that some of you all might be very upset about this, and that makes me happy. But I am destroying this book. This book is getting absolutely wrecked. Dude, oh shit. No, I don't want to arbitrarily break it. I don't want to intentionally break it like that. That was an accident. But we're wrecking this book. And part of that is that I am writing directly in pen. I'm crossing off every problem in pen permanently as we work through every single exercise in this book. So we're getting farther and farther, bit by bit. Next section, 3.2. Basic concepts of vector spaces. Okay, let's keep going. I hope you enjoy. Basic concepts of vector spaces. Determine whether the given set of vectors is dependent or independent. Okay, so what does that mean? Dude, what does dependent and independent mean here? Well, let's see. I will say that there are 4 polynomials. There are 4 polynomials in the set. They are all contained in in the second degree polynomials, which is a so they're all second degree polynomials. Are these vectors financially independent? Lol. Thanks for the notes. Absolutely, dude. I'm sorry that it took so long, but yeah, dude. I hope you enjoy. So by the fact that they're all degree 2 or less, they are all in all of these polynomials are in the vector space of second degree polynomials. The degree let's see, how do I say it? What's the best way to say? I would just say because the degree of P2 is 3, the set must be linearly dependent. Therefore, there are more vectors than the degree of the vector space that they're contained in. Or something like that. It could be cleaned up a little bit further, but that's the basic idea. We could find the explicit dependence between them if we wanted to by writing all of those relative to the standard basis. Like the first of these polynomials, x squared minus 1, this is 1 times x squared minus 1 times, well, here, let's do 1 times x squared plus 0 times x plus negative 1 times 1. This is 1 times the standard vector, oops. Yeah, I want to write them in the reverse order. Yeah. I don't know which one is considered standard and which one is considered backwards. But we typically write polynomials with decreasing degree, like x squared terms before x terms before constant terms. And it's important that a basis is ordered. It's not a set. A basis must be ordered. So now, if I say that this is the standard basis which I'm going to say E1, E2, E3. And I'll drop the x's. Now this is 1 times E1 plus 0 times E2 plus -1 times E3. So is it in this section? No, but later on, like just from this first argument, we're already done with this problem. I'm just going a little deeper and giving a sneak peek to the later sections, which we've done many times, but maybe somebody who's seeing this stream for the first time might not. We can write this first polynomial relative to the standard basis E as this coordinate vector. 1 times E1, 0 times E2, and -1 times E3. Similarly, the second polynomial in that set, x squared plus 1, I'm going to go ahead and write it out as x squared plus 1 is 1, 0, 1. The coordinate vector of P3 relative to the standard basis is 0, 4, 0. 0, 4, 0. And then the fourth polynomial coordinate vector. So I'm finding the coordinates of, I'm expressing each of these polynomials as a combination of the standard basis vectors. 0 to -3. Then from here, we can write those as 1, 0, -1, 1, 0, 1, 0, 4, 0, and 0 to -3. You can row reduce this fairly simply. Oh wait, should they be row vectors? I'm a little confused. But yeah, Happy Abe, that's my thought too. I'm trying to show the second solution right now. That's exactly what I'm trying to do. This is a second solution, which is like a little more direct. This is a first solution, which is a little more conceptual and elegant. Like Axler would prefer this first solution, I think. But then this is also a valid second solution, that you can find an explicit combination of these vectors that so that we can find the explicit we can find the exact linear combination to express them in terms of one another. Yeah, okay. In this book, a basis is always ordered. That's interesting. But that makes sense. Yeah, a basis doesn't have to be ordered until you care about taking coordinates. Like when you... One of the important things about a basis is that you can express a vector relative to that basis as coordinates, where every coordinate is a field element. So then we kind of lose that abstract vector set and only kind of like reduce vector, you can like represent a vector as a list of field elements, right? Oh, okay. You can also find a non-trivial linear combination that is 0 to show the dependence without needing to mention the standard basis. Okay, that's... Okay, cool, yeah. But that sounds a little more... somewhat tricky. I mean, I think that you could play with it and then find... Yeah, you're right. I see. That is a third solution. Now I see that. So... let's complete the second solution. 1, 1, 0, 0, 0, 0, 2, 1. We could row reduce the second line. We could add the first row to the third row. We can interchange the second and third rows. We can 0, 0, 2, 1. And now this is in row echelon form. So we have 3 equations in 4 unknowns. So we can take the fourth term, the fourth equation to be anything, and then any solution I'm going to say are let's go A, B, C, D. If we take D to be 1, then C in the third row should be negative 1/2. From the second row, B, the second coordinate should be positive 3/2. And then from the first row, A plus 3/2 equals 0. Oh, I guess I'm already solving for 0, which is similar to what you're saying. I guess I was already kind of implicitly doing that. But this is one combination. This is like a systematic combination. One combination where A times P1 plus B times P2 plus C times P3 plus D times P4 equals 0 with not all A, B, C, D all being 0. A fancy way in math to write that is if you multiply A, B, C, D all together, that this is... Oh, wait, no. I was going to say that that's not 0, but that's not true. What am I talking about? With not all A, B, C, D equal to 0. If you multiply A, B, C, D not equals 0, that says all of them need to be non-zero, but that's not true. So I apologize. I take that back. Ooh, you're working a hard question from Bonsal's calculus. Dude, why don't... All right, good for you. Good for you, man. Integral questions are hard. I mean, they can get as hard as you want them to be, for sure. So we found this solution systematically. We could test that just now that we're like going all the way down the rabbit hole. If I copy this again, then we have -3/2 supposedly times p1 x squared minus 1 plus 3/2 times p2 x squared plus 1 minus 1/2 times p3, which is 4x, plus 1 times p4, 2x minus 3. What do we get? Well, minus 3/2 x squared plus 3/2 x squared, I see that that's 0x squared. We have a plus 3/2. We have another plus 3/2. If I track the terms, we've handled those so far. We have minus 2x plus 2x minus 3. This is 0, 3 plus 0 minus 3. This is 0. So then therefore, as expected, we have a non-trivial combination of 4 vectors where they add and combine to 0. So that follows from the definition of linear dependence. This is like the direct definition of linear dependence. Ooh. Oh, 1 plus absolute value A times 1 plus absolute value B is not 1, as it's only 1 if all... Oh, that is an overkill fancy way to write it. That I haven't seen that one before. That is just super antithetical to the goal or whatever, just counterproductive. Have you ever seen a mathematician actually write that? To just say, to like get it in like math symbols. Somebody who's just like insisting, I want everything in symbols, instead of writing out English. Like that is something that in code we'd just be like, reject that pull request. No, just thought it was funny. Okay, well you made it up. I'm gonna with a straight face use that sometime. I've never. Yeah, that's good. I like that. Well, wait. Oh, yeah. That does work. Yeah, doesn't it? I like it. Nice. Okay, so then solution 3 for the same exact problem. It's kind of a guess and check approach. Of 2, which is not wrong. It's not bad. It's pedagogically good, I think, for a book to try to pressure you into like just try to find one, dude. Like try to find one before you learn like a systematic approach like this. Like maybe you can discover this systematic approach on your own by playing with these polynomials. Like we want A times x squared minus 1 plus B times x squared plus 1 plus C times 4x plus D times 2x minus 3 equals 0. I think that you would set this up by claiming, I think, that this is linearly dependent. If so, then, and then you set up that approach, we could take because P1 and P2 are the only terms with x squared terms, take b equal negative a, and for example, maybe a equals 1, b equals negative 1. That's going to get us something different, right? We should get a different answer than this if we took this approach. Then, a times x squared minus 1, we'd have, well, if we combine Yeah, I want to recombine all of them into the different powers of x, but then, yeah, we kind of reconstruct solution 2 a little more explicitly. So we have minus a plus b plus 4cx plus 2dx minus 3d equals 0. If a is 1 and b is negative 1, then the first term is 0. Negative a plus b would then be negative 2 plus 4cx plus 2dx minus 3d equals 0. Here, I could notice that I can combine the x terms, 2c plus d. So I factored out a common factor of 2, and I factored out the common factor of x. And then minus 3d equals 0. Then 2c plus d must equal 0. So, for example, 2c plus d equals 0. Oh, and negative 2 minus 3d equals 0. So, well, from the second one, we can get d. 3d equals negative 2. 3d equals negative 2, so d is negative 2/3. And then c is negative d divided by 2. Negative d divided by 2 is 1/3. And now we can go back and double check that we didn't make any mistakes if you want to. But this is another combination of those 4 vectors that add to 0. And therefore, this is by definition, a linearly dependent set of vectors. But I have seen equations used in proofs to encode certain properties kind of like that. Yeah, I mean, it seems pretty clever, actually. Like, no, I believe that you would use something like that in proofs. And I've never realized it, but I like that a lot. Yeah, because the absolute value is 0 if and only if the number is 0, and then therefore, yeah, if the only way that the product of all of those terms this is greater than 1 is if one of the absolute values is greater than 1. I like it. Yeah, I think this guess and check will kind of just become the last solution with a different join of A, B, C, D based on your starting choice for A. Exactly, but I think that there's something pedagogically useful about seeing these different approaches, the different solutions, and how if you do go this direction, how do I get rid of this annoying play UI button thing? I think that there's something valuable about taking something that's kind of like the substitution method. This is pretty much like the substitution method when we teach solving systems of linear equations. And then after you learn it with this way, which is like by hand doing the calculations, trying to substitute variables for other variables, then you go to the elimination method. At least in the US, we teach in high school the elimination method where you're still writing out the full equations, but you're adding and subtracting equations to eliminate a variable. And then some schools in high school will teach it, and then others save it for college, I think. But elimination method, you can just write as matrices. Matrix elimination method. It's the same exact process as elimination method where you're writing out, the equations and you're adding and subtracting equations to each other. But now you just lose all the variables and you write all of those steps as matrices instead. I think that what I'm trying to get at is that I think it makes sense for pedagogy to go start with 1, do the solve it by hand method, then go to something a little bit more sophisticated, then learn how you can write that in a more succinct way, and then go to more conceptual, like theoretical proofs. I jumped right to the theoretical proof of this solution because, I don't even need to know exactly the linear combination to answer the question. I knew because there's 4 vectors in a 3-dimensional vector space, one of them must be linearly dependent. At least one of them. Or the set is linearly independent. Or linearly dependent, yeah. Yes, Happy Abe. That one is much more sane, I think. Absolute value of A plus absolute value of B plus absolute value of C plus absolute value. The sum of the absolute value is greater than 0. That is a much more sane way to write it. I like your refactoring there. But even that is still clumsy. I would reject that in a pull request. I'd be like, don't try to be so clever. Just write it out in English. But I could see that being incredibly useful in a proof. If you're told that not all of them are equal to 0, you can substitute, the sum of the absolute values. That's really cool. I do remember things like that you use in analysis and epsilon delta proofs all the time, right? I'm so frustrated with inverse trig functions. Ugh. Yeah, that sounds tough. Kinetic. Okay. Cool. And then, as we just talked about, I was giving a sneak peek to coordinatization. But this is actually in the next section. Where you can write a vector as just the coordinates. So, yeah. Any questions? Anybody? Any thoughts? Any feedback? I'll pause and let you all work this problem for a second. Yeah, I think that this channel is coming nice. Oh, yeah, take care, dude. I don't know if I'm streaming guitar today, but hey, dude, Kinetic, if you are curious, I streamed an awesome guitar stream yesterday, I think. Bro, check out my video from yesterday. Somebody posted as me on Reddit. Dude, somebody posted as me on Reddit without my permission and posted a video. And then there were responses where people were saying that guitar is a crime. And they're not wrong. They're not wrong. Like, you're valid. Your opinion is valid. And I'm not saying that you're wrong. But I love it. It makes me very happy to write all over the guitar. What do you all think? What do you all think? Seriously. Like, what is your opinion of this? What's your first impression? Imagine that you didn't know me and you saw me in the park playing a guitar that looks like this. Like, what do you what's your first reaction? Because my impression, I thought that people were going to be like, whoa, how cool, I love it, like, what's up with that, what's up with the names, like, or like, I thought people were going to be walking by and being like, you are crazy, or like, you are insane. But it seems to be so upsetting to people, so shocking, that they just walk by and they don't say anything. They're just like, don't look at the guy with the face tattoo. They're just like, don't make eye contact with the guy with the scary face tattoo. Keep walking. Don't make eye contact. That has been the impression. It's like, okay, understandable. That's valid. Like, what did I expect to happen? Math or guitar? Or both, my friend. Both. I am a streamer in mathematics, and I'm a streamer in classical guitar. So if anybody wants to see some classical guitar, you can follow my second channel. We're just taking a short break right now. We're going to get back to math. Don't worry. I have a second channel in classical guitar. Math is a wonderful thing. Jack Black, School of Rock. Hell yeah, dude. I'm interested in finding all of the weird niche people who are interested in both. Because there are a lot of people out there who are interested in music and math. I think that there is something to the idea that there's like similar ways of thinking, similar analytical thinking, or maybe just an appreciation for beauty, honestly. Like, they're both beautiful things. To me, they're both very beautiful. Some people really enjoy math because they like a certain type of beauty, and that's me for sure. But yeah, people got very upset on Reddit. I posted my follow-up video on Reddit. I got obliterated. I got -9 downvotes. I got 9 downvotes, and I just got obliterated. And people just posted again, that crime, or that guitar is a crime, though. They just like repeated the same comment. It's like, valid, you're not wrong. I appreciate your opinion and your feedback. But something that's important to realize is that it looks like I wrote directly on the guitar. That's what I want it to look like. But it's all pieces of vinyl that I can take off. It doesn't hurt the guitar. I'm not writing directly on the guitar. They're all little pieces of vinyl that I can just take off. I can move them around. Static cling. It doesn't hurt the guitar at all. I can move them. There's no sticky residue. It's not stickers. They're just like pieces of vinyl that just cling to the guitar. But it makes people mad as hell, apparently. And I love it. It's like, yeah, dude. Why not? I'll do it for $1,000. I'll write on it. I don't care. Maybe for 100. I don't know. Maybe for 100. Sadly, I don't understand music even a bit. It's never too late, dude. There was a interview with Luffy, with the author of the Chapter 0 Algebra book and other books. And he was talking about how he's learning music late in life, and interesting the vinyl sticks so well. Yeah, isn't it super cool? Like, I don't want to take this one off because I've been taking them off. The ones that like if I shine it in the light in the right way, you can see that they are. It's hard, but like it looks so good. It's hard to tell from a distance, right? But I think you can see now if I shine it correctly. It's just totally. They're all just pieces of vinyl that I can move. Yeah, and then it's static cling, like. No residue. It's just static cling. I should probably redo some of these. Like this one is a good friend of the channel. Long time friend of the channel. And it's gotten some dust in it. Like there's like a little bit of dust that they collect. But yeah, just little pieces of vinyl. No problem. Doesn't hurt the guitar, dude. But it looks like it, and why not? Yeah, people got very offended on Reddit. Spanish guitar? Cars Daro, do you want some Spanish guitar? I could play you some Spanish guitar right now if you want. But you have to hit the like and subscribe. You have to hit like and subscribe and ring the bell, and I'll play you Spanish guitar right now if you want it. Otherwise, we can get back into math. I don't get how they don't fall. I know it's beautiful, just like static cling. It's amazing. I don't understand it either, man. It's like weird physics to me. Like, how do they not fall? Like, if I do this, they don't fall. They're like static cling. Bro, do I explain Diffie Q? No, I do not. No, dude, no. Eventually we will in the calculus series. I do calculus, linear algebra, and representation theory. Okay. Anyways, thank you. Let's keep going. So, we want to find A, B, C, and D in the real numbers such that A times our first matrix, which I'm just going to say, no. Let's call this matrix B, and let's call these matrices A1, A2, A3, and A4. Let's do this. Then A times A1 plus B times A2 plus C times A3 plus D times A4 equal B. Then A times A1 is 0A, A, 0. B times A2 is 0, negative B, 0, 0. C times A3 is C, negative C, 0, 3C. C, negative C, 0, 3C. And then D times A4 is 0D, 0D. And all of these need to equal the matrix 1, negative 2, 3, 4. Now, I have 4 equations in 4 unknowns. Because the top left entries add up like that. The top right entries, oops. The bottom left entries, a plus 0 plus 0 plus 0 is 3. And then the bottom right entries, we get this system of equations, which is not too bad to just solve by hand, honestly. But we could solve it with a matrix if we want to, but we already have C is 1, so then the bottom equation, we have D is 4 minus 3, D is 1. We already have A being 3 in this one. We already have C equal 1. And then the only equation left is the second equation. 3 minus B minus C plus D equals negative 2. I'm going to do it in my head, but in my head I'm thinking that B is 2 plus A minus C plus D. I mean, I could have done it in my head and think of it with that rearrangement. I added 2 to both sides. I added B to both sides. But 2 plus 3 is 5. Minus 1 is 4. Plus 1 is 5. B is 5. So therefore, our coordinate vector of matrix B relative to this set is this coordinate vector 3, 5, 1, 1. Yeah, why are you all retracting messages? I'm not reading them while I'm working problems. I'm gonna focus, I'm gonna lock in and work a problem or two and not even read chat and then come back and I'll read. So yeah, you don't have to delete your messages. Yeah, isn't the vinyl is super cool physics, isn't it? Bro, kinetic, it's gonna be like a year. I don't think I'll ever get to integrals. I think I'll have to delete my channel before we get to integrals. I apologize that the iPad is updating slow. Please let me know when that happens. I have to keep an app open for it to make sure that I apologize. It should be better now. Okay. Yeah, don't delete your messages unless you have to, but all right, we're done with this one. So, I know, I hope I don't have to delete the channel. I really hope I don't. But if there's a fancy private school that's going to pay me a bunch of money to be a math teacher there, if they don't want me to have a live stream, I will delete it in a heartbeat. But I really hope that that's not the case. Dude, I'm not going to make any money off of YouTube. YouTube is a freaking scam. It is exploitation of people who want to become famous and are willing to do free work trying to become famous. Don't at me, bro. Don't at me. I'm sorry. I'm the only, I'm just going to be extremely blunt about that. Yeah, I don't think that's going to happen. I think that for the right school, they're going to be like, yo, that's awesome. Like, the right school would be like, dude, why not? Like, that's extra free work for us. Like, it could be office hours, I think, for students. Like, this could be office hours in a really cool way. I think that this could be a really dope thing on my portfolio. Yeah, it's true. AI took my job. It's fine, though. I mean, I'm kind of happy about it. I got a really beautiful severance package. Like, I had a wonderful severance package, and it gave me the courage to try to do my own thing and try to build my own brand, build my own business, try to become a creator, try to do other things. JC's homework hotline. Dude, I'm not joking. If we get monetized, when we get monetized here, it could be like the guitar stream. Leroy's a regular in the guitar channel. Dude, did you see this video yesterday, by the way, Leroy? It was wonderful, because I talked about my busking, and I write names on the sheet music, I write names on my guitar. If you pay me, I will happily put you on my guitar. And we could do the same thing in math. Like, if you pay me $1, I'll help you work with your problem. It'll probably be $5, but like I'll solve your homework for you for $5. Cool, check it out. Please do. I think it was an awesome video yesterday, Leroy. It's in the live tab, obviously, and please, if you don't mind, leave a comment. Just say like, hell yeah, I love the guitar, or whatever feels authentic to you. I would appreciate it. I got wrecked in Reddit. I got -9 votes. I got downvoted to -9. Yeah, they're mad. They're mad at me right now. Yeah, the whole world needs math. Yeah, man. The whole world out there needs math. It's true. You opened the video. Awesome. Please do. Check it out. I think it was a good video yesterday. I think it was a really good video. Marco Topci, like a super famous guitarist, like one of my like idols, one of my guitar heroes out there, commented on the video and said something essentially like, hell yeah, like awesome job or something. It's like, dude, that's so cool. Like, I'm like geeking out. Tips for buying a guitar. Sign up for my guitar channel. I'll see you there sometime. I will talk about that on the guitar stream. Yeah, the Eagles are nice. I like the Eagles. Yeah, I don't play any Eagles, but no, I don't know that one. But yeah, what I'm trying to say right now is we could totally make this a homework hotline. I'll solve your problems if you want. Like, pay me and I'll work your math problems. I'll try my hardest. I'll solve any math problem. I'll try to solve any math problem for $1. Okay, let's keep going. Section 3.4. Like, I will help Happy Abe with his math, or Levi, or like Leo lectures. I'll help Leo and K-Theory with their math if they pay me. Nah, calculus sucks, man. But yeah, I am doing calculus because I think it'll be good for my channel growth, but it's not as beautiful to me. I'm glad you like it. Go watch my calculus videos. Okay, linear transformations. Let D infinity be the vector space of functions mapping R into R that have derivatives of all orders. So you all know a word for this is a smooth function. A smooth function has derivatives of all orders. Hey, you wanted some calculus. Here you go, dude. Here's some Grad school math homework help, yes. Yeah, I'll try my hardest. I probably won't be able to help at all, but I'll spend 10 minutes helping somebody with their graduate level math. It's actually going to be them explaining to me the whole time what the, I'm not going to be very good help, but I can try for 10 minutes. Ooh, yeah, the Lambert W function. I've heard of it. Okay, so we have some calculus. Here you go, dude. We have a vector space of continuous smooth functions. It can be shown that the kernel of a linear transformation of the form... Ooh, neat. It can be shown that the kernel of a linear transformation... Ooh, okay, so the kernel is an n-dimensional subspace. Ooh! I think that makes sense to me. Dang, okay. In exercises 10 to 15, use the preceding information, summary item 10, and your knowledge of calculus right in time for our new friend to find all solutions in d infinity of the given differential. Dude, you were just asking for a differential equation. Bro, here you go. Okay. This I'm gonna actually kind of pause with. Happy Abe, yeah. That could be it. Like, if you all pay me, I will study any math that you all want. Yeah, this is... Calculus at the high school and undergrad is super boring. It's just calculations, and... Yeah, you can make calculations as freaking hard as you want to. If you want to make those... They can be as hard as you want, and you can do competition math with, like, hard calculations. But that's not beautiful. That's not conceptual. That's not real math. Okay. So we want to find all solutions of this given differential equation. Okay. So we have y prime is sine of 2x. Let f of x satisfy the diffie q So the derivative is sine of 2x. Can we... I mean, this is like saying... I think that this exercise is kind of just challenging you to understand this terminology of like kernels and yeah, exactly. This is a matter of like we know an explicit antiderivative of sine of 2x. The antiderivative of sine 2x is of the form negative 1/2 cosine 2x. Is the derivative of cosine negative sine? I think that's right? Like, dude, that's how long it's been. Plus any constant but it doesn't necessarily have, we don't know a priori that it's a constant. We know where h prime of x equals 0. In other words, h is in the kernel of our transformation. I think. Be quiet. It can be shown that the kernel of a linear transformation of this form. So, I mean, this is like a warm-up problem. Because from calculus, I think that we're all used to solving this antiderivative and finding an explicit antiderivative, which would, for this, is negative 1/2 cosine 2x plus c for any constant c. But in the later exercises, we have to solve a more difficult antiderivative, or like we have to solve differential equations that are not as trivial. So maybe we'll do both of these and try to see if we can solve both of them. Because I think this is it, right? I'll say y is negative 1/2 cosine 2x plus c. How do I... Am I really applying this? Is an n-dimensional subspace. Am I really applying this property? Like, in this statement, our transformation of a function f is f prime is 1 times f prime. Hi, Kaya. So this problem statement tells me that the kernel of T is a one-dimensional subspace of D infinity. The only one-dimensional subspace of smooth functions is the span, the span of the constant of any constant, the span of 1. In other words, if h of x is in the kernel of T, then h of x is in the span of 1. In other words, h of x is a constant times 1. So now I've rewritten this a bit more to actually truly apply this statement, this fact, whereas we could have solved this antiderivative directly just using calculus 2. I'm a little nervous because right now, I do not actually know differential equations very well. So forgive me if I'm a little a little funny on this one. But I think that that's good. I think we're right on this first one. Now let's try 13 so that we get a more interesting problem. So for problem 13, we have y double prime plus y equals x squared. No, plus 4y equals x squared. Yep. Let t be a transformation of smooth functions into smooth functions such that t of f is f double prime plus 4 times f. That's the left-hand side of this differential equation. Then, by the theory, then by the fact given, the kernel of this transformation is a two-dimensional subspace of d infinity. Can I say that? Oh, dude, I can't say that the kernel... The fact that it's a one-dimensional subspace does not imply that the span... That the... Just the fact that it's a one-dimensional subspace doesn't mean that it's a span of 1. So that logic, that argument, fails in that step, even though the conclusion is correct. We just need 2 parts. We need that part and the part B, that 1 is in the kernel of t. Like 1 is any constant function. The derivative of a constant is 0. So that part is necessary in order. So then the constant functions are in the kernel of t, and then because it's a one-dimensional subspace, then therefore every element in the kernel is a scaling of the constant function. There we go. I was missing something there. Hey, you were listening to the guitar jams. Hell yeah, man. The end of that piece is awesome. Which one? Yeah, exactly. That's what I was thinking too, Happy Ape. You find a particular solution, and then you find anything in the kernel of that transformation. Like that's... I see that this is the right direction. So, can I find... Since the kernel of this transformation is a two-dimensional subspace, let's see. Let let's say that the two-dimensional subspace is given by H1, H2 be a basis for the kernel of T. Or we want to find two independent vectors in the kernel of this transformation. Then T of H1 is H1 double prime plus 4H1, and that equals 0 because H is in the kernel. Therefore, we want some function H which is negative 1/4 times its second derivative. Or maybe it's better to say H1, its second derivative is negative 4 times itself. There should be two independent solutions to this. Well, I see one. Turns out sine of 2x, we get this, right? I wonder, is there a more systematic way to do this? The derivative maps that to 2 cosine of 2x. And then the derivative of that maps to negative 4 sine 2x. So we have one function that's in the kernel. If we can find any other linearly independent vector in the kernel, then we know that those two form a basis for the kernel. There is no scaling of sine that equals cosine, and I think that cosine gives us the same property, right? Doesn't cosine behave exactly the same way? Sine of x and cosine of 2x, because cosine 2x maps to negative 2 sine of 2x, and then that maps to negative 4 cosine 2x. So now we have then, by the fact given the kernel of our transformation is the span precisely of sine 2x and cosine 2x. Any solution to y double prime plus 4y equals x squared, any solution to this is of the form y equals p of x, some particular solution, plus any scaling of sine 2x and cosine 2x. How do we find a particular solution? I think that we could find a... How do we find systematically... Dude, I feel nervous right now because it's been 20 years since differential equations, and this kind of stuff is I'm actually extremely rusty on, but I think that we can find it. Oh, well, let's see. The second derivative of x squared the second derivative of x squared is 2. So I think that we're close. Four y is x squared minus the second derivative. Can I take the integral? No, we don't do that. No, we don't. We don't want to do that. What's the right way? Can I take the derivative of both sides? That's not what we do. Dude, we're so close on that. I think it's like some scaling of x squared. I think it's some scaling of x squared, I believe. If so, then it's kx squared is 1/4 x squared minus, if this were kx squared, we'd map to 2kx and then to 2k. Therefore, therefore, k has to equal... Oh, dude, this is not right. K simultaneously needs to equal 1/4 and 0, right? So then I think that this is not. It's not a... I don't think that there's a... Oh, okay. It's not a scaling of x squared. That's a particular solution. Yeah. Because we simultaneously get k equals 1/4 and... k equals 0, so this is a contradiction. So it's not what my first thought was. Have a good day ahead. Have a good day. I'm gonna actually read the section now before I look at the hints, because dude, like, if there's anything that I can offer that's unique and new and kind of, in my opinion, cool that I would like to see when I was a student is, like, what does it look like for somebody figuring out and learning math in real time? Not a presentation of somebody who already understands a problem, who already knows the solution and is just teaching, but what does it look like to try to figure out a problem in real time? Like, so I'm going to try not to look at chat, even though I think people are being helpful and giving me tips that maybe are even better than my approach right now. But, like, I'm going to try to see if we can figure this out. Yeah, I remember this notation. The solution set of Tx equals B. Oh, okay, wait. Yeah, okay. No, I wrote this the same. It's the same. We got the same thing. I just want to rewrite this theory. So, and this may be incredibly boring and annoying for people who are live in the chat and you're just, like, screaming at your television set right now, like, bro, just read the chat, like, you went the wrong way earlier, something went wrong. But this is, I think, where I can offer something that's unique and new to Math YouTube. For better or worse, let me know if that's not interesting to watch. So I'm going to review my notes and read the section. Let T map V into V prime be a linear transformation, and let T of P equal B for a particular vector P in V. The solution set of T of X equal B is the set P plus H such that H is in the kernel of T. So this is exactly what I remembered. And I didn't state it so precisely, but that's really nice to write out the exact statement from the section. Now, a condition for T to be 1-to-1, a linear transformation T is 1-to-1 if and only if kernel T is 0, is trivial. So, condition for T to be 1-to-1, it's true if and only if kernel is trivial. This is another little fact. Okay. Illustration 1. The problem gave me the tip to take a look at illustration 1 in the text, and I haven't done that till right now. but y double prime plus, it's a very similar approach. In illustration 1, they solve the differential equation y double prime minus 4y equal x squared. It's linear with constant coefficients, and it's of the right form. In example 5, we showed that the left-hand side defines a linear transformation of d infinity into itself. In differential equations, it is shown that it says in diff EQ, it is shown that the kernel of T is two-dimensional. We can check that the independent functions h1 of x equals e to the 2x and h2 of x equals e to the negative 2x both satisfy that differential equation. So I did something extremely similar. I used the same notation. I vaguely remember this example. So this forms a basis. We find a particular solution by inspection. Yeah, again. Okay, so we find, this is exactly the approach I was trying to take. We find a particular, okay, so at least I was on the right track. We find a particular solution by inspection. So let me try again to do this by inspection, because I want, yeah, I was super close. Okay, so we find a particular solution by inspection. They say, for this example, if y is negative x squared over 4, how are they picking? If y is negative x squared divided by 4, then negative 4y, they pick that, so negative 4y is, yeah, okay. Negative 4y is x squared. So that's what I want. That's the approach that I want in this solution. So I was extremely close. It's just that we want, in ours, if 4y equals x squared, I was so dang close. Okay. We can take y equal x squared over 4, then y double prime is 2x over 4, and then y double prime is 1/2. So we need to just adjust slightly. We fix or something. What do they say? We kill off this unwanted negative 1/2 by setting our particular solution, p of x, being Yeah, our particular solution then is going to be x squared over 4 minus 1/2. So that the second derivative of the first term is positive 1/2, then you subtract 1/2. Right? Yeah. Now we have a particular solution. I think. Is that correct? P of x equal x squared over 4 minus 1/2. H1 of x sine of 2x. H2 of x cosine of 2x. Right? And so then note that the second derivative... Oh, wait, shoot. No. Well, 4 times p is x squared. Right now, 4 times p is x squared minus 2. And that doesn't match up. We need a different... I'm trying not to, read the text directly and just copy it. I'm trying to, reconstruct their logic. So I got this constant wrong. But we're close. So this is the approach. It's just I'm writing the wrong constant, right? The second derivative... Oh my god. Okay. It's plus some constant. The second derivative of p plus 4p is 1/2 plus x squared plus 4c. And because we want to set that equal to x squared, then therefore c, 1/2 plus 4c have to add to 0, so c is negative... Wait, 4... Yeah, negative 1/8. Negative... If 4c plus 1/2 add to 0, then 4c equals negative 1/2. C is negative 1/8. There it is. Okay. So any solution is of the form x squared over 4 minus 1/8 plus what constant or what letters do they use? C1 sine 2x plus C2 cosine 2x. And this is our solution. Every solution to that differential equation is of that form. All right, thank you for watching me struggle, but we got it. We got it eventually. I feel pretty good about that eventually. Yes. The homogeneous solutions. Yeah, I'm trying to understand the pedagogy from this book, which doesn't assume a class from differential equations. I had a feeling, like, just generally remembering, like, I'm pretty sure that there is, like, a general, more systematic way to solve this, but in this example, they're trying to show this concept that the kernel is two-dimensional, and I found that two-dimensional basis, and then any particular solution, so like any solution is going to be a particular solution, but plus an element of the kernel. I got 1/4 x squared minus 1/8. Is it minus 1/2? Yeah, so at least I'm not the only one who made a mistake. At least you also made a mistake in this constant. Because you said minus 1/2. I think that's what I said the first time. Or somewhere around, along the way. I was trying something sort of similar. But I was trying to just do a scaling of x squared. So I could have realized... Well, I'm not going to bother trying to go a little more than that. Finishing up AI slop review stream. Dang. That sounds cool. And thank you. Thank you for sending your friends over here, Leo. I just saw your message. I apologize, everybody. Usually I'm a little more confident. I'm not very confident on differential equations. Hello, welcome. I am relearning math after 15 years away after graduating with a bachelor's degree in pure math. And now I'm relearning math and practicing every day on YouTube in order to get a job as a high school math teacher. You probably don't need differential equations and linear algebra to teach high school math, but I want to study this stuff for myself because it's fun and it's beautiful. Thank you for joining the after party, the JC after party. What you working on, big dog? I'm learning about linear transformations, my friend. This was a problem, and we were applying the concept of a kernel and understanding the kernel of a linear transformation and learning about the kernel of differential equations and mapping a function, a smooth function, to a sum of derivatives. Check that p of x is a particular solution. I think I did it. Holy, he's cooking. I eventually got there. Nice. Using plus c will definitely help. You made the same mistake I did at first. I'm glad, man. All right, well, we got there eventually. All right, let's cross that one off and hope that we never have to solve another differential equation again. I feel quite rusty, and I would like to work through a Diffie-Hughes book someday on stream, but we're trying to be laser focused. So wait, Leo, tell me more about your AI slop stream. Yo, we just went from problem 10 to problem 13. Whoops. Okay, well, we skipped problems 11 and 12 along the way. What kind of psychopath book, like, lists these problems in this order? Dude, this book listed the problems like this. 10, 11, 12, 13, 14, 15. And then 16. Like, what kind of crazy book would order in columns like this? I just automatically assumed we'd go 1, 2, 3, 4 in this 2-column flow. Am I crazy? Am I wrong? Am I the wrong one here? Oh well, at least we jumped up in difficulty from problem 10 to problem 13. Heck yeah. 13 problems is equal to 3 problems, so it's fine. I guess. Yeah, I mean... Yeah, I don't know. We got there eventually. We did it. We solved 2 differential equations. That's 2 more than I thought we would do today. There's problem 13. We did it. Let's keep going. Is there another section, or are we... Oh, we got inner product spaces. Inner product spaces is optional in this book, and we've already gone for more than 2 hours. I think streaming any more than 1 hour is probably counterproductive to our click-through rate. So this one is an optional section in this book, and I'm going to take the invitation to frickin' skip it this time around. All right, thank you everybody for watching. Please do like and subscribe. And bro, Leo, and everybody else in the chat, I filmed an awesome, I think a really good video yesterday in my guitar channel. Let me read your... Yeah, dude, I do think that we should be learning how to use AI in smart ways. Like, don't freaking let influencers or creators or the general milieu, the zeitgeist of like negative feelings about AI prevent you from like using it, because the freaking capitalists like people are using it to build and do awesome shit. Like, you can do awesome shit. It's just that you have to have good taste about how you use AI. We should be using AI to build awesome shit because other people are. It's a matter of learning how to use it effectively. So if somebody wants to pay me $1 to work their homework problems, we were ranting about this earlier today. If somebody wants to pay me $1 to work their homework problems, I'll happily do it. Leo, I will help you with your graduate level math if you tip me. Man, if you tip me, I will help with anybody's homework problems. And guess what? Like, dude, you are paying for the entertainment of watching somebody try to learn math. If you just want problems, if you just want solutions to your homework problems, ask ChatGPT. It's going to do a better job than me. It's going to answer these questions in a fraction of a second compared to me. Use AI in smart ways, just the same way that, yes, the answer is in the back of the book. Yes, there are solutions manuals online. You could just look at the answers, but that would not be learning properly. I struggled just now, and I recorded myself struggling because this process is going to get you to learn the material better than if you look straight at the answers. So, but then as a builder, as a software engineer, as an indie developer, of course I should be using AI, and I do use AI at times. I use AI all the time to ask questions and other things. Don't let people who complain about water usage or whatever prevent you from learning how to use this invaluable tool, man. I can rant about it. But then your other comment is really interesting. You use Claude. Totally. I just use ChatGPT, as a vague term. I have no allegiance or any preference between them at all. But your other comment, I think, is super, super, super interesting, and I agree with. Generally, for streaming success, I think most of it is consistent time. I don't know if you were responding to one of these. I don't know if you were responding to a comment from somebody else, maybe something that was retracted, or maybe I said something randomly. But yeah, like consistent streaming schedule is key. I misread your comment and said that, or I thought that you were saying that the benefit to you of streaming is consistency. And that's a different statement that I would argue to you. Like, streaming is fun. It gets you into the habit of streaming consistently and studying math consistently. Like once you get kind of in the flow of it and you start getting some attention and you want to build a schedule, like at 9 a.m. Eastern every day, I'm practicing math. At least weekdays. 9 a.m. Eastern, weekdays, I'm live and I'm studying math. It's quite a good little virtuous feedback loop if you can be productive, if you can learn how to do something valuable, not video games, but like studying math or guitar, and you can learn how to ignore chat appropriately. That takes time, that takes skill, that takes practice, but it can be, I think, very much a net positive because it drives consistency. It drives you into a schedule, and it's like, it's a good forcing function to pressure you into like doing the thing. As long as you're streaming something that you want to be doing anyways, I think it's a really cool way to build consistency. So, sheesh, yeah, I could use help on some stuff. Yeah, pay me and I'll help you with your math. I'm not gonna do a good job. I'm not gonna be able to help, but I'll try my hardest. You know. I know one of the reasons I don't want to stream, at least for streaming's sake, is that success with it is based on consistent time. Oh, and you're saying that you're unable to build a consistent schedule. Yeah, consistency is so key in streaming. Consistent schedule, people who expect that their favorite TV show is on at the same time every week or every day, like whatever frequency that you want to do. Yeah, you have a friend who's morally pushy against AI use because of the water and political capitalist things. Yeah, right. I agree with you, Happy Abe. Like, don't limit yourself and not use it because of those reasons. That's how they're gonna win. Like, the other people are gonna win if you don't learn how to use this like incredible alien life form that we've invented. Like, I don't like it, but I know that I need to learn how to use it, or else I'm going to be left behind in skill. Like, especially in the software industry, like I'm just going to be left behind. I'm coding with like hand-chiseled, artisanal, handcrafted, hand-chiseled code. Like, nowadays, code is completely different, and we should all be learning how to use technology in smart ways. Don't just tell it to build you a business and it's going to create the most generic AI slop ever, but learn how to use it intelligently. And I'm so interested in that. So I look forward to watching your video, Leo, because yeah, it's just a big research question right now. How do we use AI intelligently? That's a net positive. And yeah, there's a smart, subtle counter argument against the AI, the water usage even. Like, it's just such a nuanced thing, and like some people just are at surface level understanding of the pros and cons of AI. Like, people who are like AI critics, but they have surface level understanding of it. I'm just like, no, you need to inform yourself much more, my friend. There are good reasons not to use AI, but water is not a good reason not to use it. Yeah, I do think the left side of the world It's quite reactionary against AI. I think there are lots of problems that we should be thoughtful about, but the idea that it's not going to be used is very naive. Yep, completely. Yeah, that's dumb. Like, it's just dumb not to learn how to use it for the wrong reasons. Yeah, people want to put the toothpaste back into the bottle. Yeah, I miss 2019 before the pandemic. I miss when we all worked in the office, but the toothpaste is not going back in the bottle, man. Like the tech industry has changed. Remote work is here to stay. AI usage is here to stay. Like, the world is changing, and if you don't change with it, you're going to get left behind. I think so, very much. Because then you're like, we live in a competitive capitalistic world. Like, competition is the definition in some sense. Like, we live in a competitive world, and if your competitors are using this incredible tool, that you're morally against, you're gonna have a hard time. So, I don't know. I use very little AI myself, but it's because I'm a little more interested in human-focused art and human-focused skills and craft. I don't think that AI right now makes me a better YouTuber, so I don't use it. But I want to be a better high school teacher, and I want to be a better YouTuber and a better musical artist. And I would use AI if I felt like it would help me for those things, but I don't think it helps me for those things. Yeah, Hank Green. I've seen some of his videos about AI stuff. I don't know if I saw the one about the water, but yeah, it's nothing compared to corn or agriculture, like freaking cows and stuff. Some people just have the most basic surface level understanding of the pros and cons. I'm on the con side. I'm anti AI, but I'm not saying that we should put the toothpaste back in the bottle. That's impossible. That's incredibly naive. Like, that's just not going to happen. So, yes, Leo, I hope that your video touches on this. Yeah, I'm very concerned about people sacrificing all their agency to the chatbot and being like, bro, bot, tell me what to think and feel and do. Yes, that is exactly where there can be this division of people who learn how to use it intelligently for a net positive, and then other people who turn off their brain and just delegate to the chatbot. I know smart people who are going down that path, who are just like, bro, build me a tech startup. Just do it all. Like, just vibe code. Don't need to read the code. Don't need to understand anything. Just build me. Just build. And, it's just there are smart ways to do that, and there are dumb ways to do that as well. Yeah, if you're not mathematically mature and have knowledge background, you would just trust it without verifying. Yeah, we still need to learn classical arguments. Like, we can't just jump right to AI-assisted lean in an intro to proofs course. You still need to do the hard work that is never going to get easier of learning mathematical maturity. Learning mathematical maturity is hard. That's a hard gap that most people don't make it through. And AI is not going to make it easier to cross that gap, I feel. If anything, I think AI is going to make it harder to develop mathematical maturity, because some people are just going to jump to it too early as like a solutions manual or something. Culture, especially American culture, has difficulty with nuance. Yep. Yeah, Leo. Yeah. Such a good point there, man. Such a good point. Yeah, we in America have a very difficult time with nuance, and there are pros and cons and a subtle, complex argument to be had. And I know people who are very pro and people who are very con on it. And they're both right in different ways. It's really just legitimately a political topic, and it seems like it's starting to finally be recognized as a political topic like this. Like, it truly is a political issue. And in my opinion, one of the most important political issues right now. Yeah, how do we work with AI productively for everyone? Well, there's some people who say we should turn it off. We should find a way to turn it off, and we should do everything we can to turn it off. Like Eliza Yudovsky and, people like that. And I'm not going to say that they're wrong. Like, they've got a nuanced, subtle, intelligent argument for it. I don't know if I agree with that at all. But there are smart people out there who think we should just turn it off and find a way to turn it off. Or have a moratorium and just stop AI development. My thought there is, like, good luck. Good luck doing that. That doesn't sound realistic. That sounds a little idealistic. Unless you follow Leo lectures, and you'll learn everything easily and for free. Here you go. That's a funny comment that made me laugh, so let me give you another one of these. What's up, man? I was trying to say earlier, dude, Leo, I know that you're a guitarist, apparently. Check out this, man. I got obliterated in Reddit. I got obliterated, like, -9 downvotes. I got 9 downvotes. I got cremated in Reddit, posting about my guitar with the names. Yeah, they are after it. They're upset. So I have a new video called "Does My Guitar Make You Mad?" I hope you check it out, because I think that this video could grow, and I get into some, I think, really interesting discussions. It's a live video essay. I play a couple of songs. I chat with chat a little bit. So there's a 37-minute runtime, but you could skip the songs, and that shaves like 10 minutes off of it or something. So I hope y'all check out this video. I do think it's worth your time. You could watch just 10 minutes, and it's like, I think, a pretty good video. I'm trying to get better at doing a video essay on YouTube. Like, I freaking show up, do it live, though. Like a live video essays. I thought watching the AI slop chat Chaitin's constant video, I don't know what that is, was very interesting because narratively it did a good job. The AI voice was uncompelling. It felt like slop. I don't know what video you're talking about. Will I see it? Leo, could you link your new... Well, I can do this. I look forward to watching your rant about AI. Just don't get too far away from math. You might freaking go viral and get 10 times your views. It's hard, but stay principled, my friend. Stay principled. Stick with math. But also include AI in your rants and discussions and everything. But just don't pivot away from your legit content. Unless that's what you want to do. I don't know. Do whatever you want. The only opinion on it / unique takeaway thing I would say is wrong. Okay. Basically all other facts were correct. Reacting to a video on stream. Okay. Yeah, stick with math. I mean, but back to the topic, bro, use AI to help you write that linear algebra book. Why not? You should. Or you should vibe code the interactive version of that linear algebra book and use it as a tool to build something that you wouldn't be able to build otherwise. That's awesome. That's a great usage of AI, you know, get it to like create like a first draft if you want, but then edit it into your own words. You know, you're gonna know where it's just like either hallucinating or just mid as fuck. Like it's no longer like hallucinating as much as it used to, but it's still mid. It's just so mid. And now we have an abundance of content out here, of high quality content that we're all giving away for free. Like, we don't want to spend our valuable time on mid stuff. So the bar keeps raising. Like, it's a competitive level, but you could be AI assisted and help you make something awesome. Like, it can do all the grunt work of a first draft of some sort of book or something, or an outline or whatever, and then you use your human creativity and your expertise in order to flesh it out and make something awesome, right? Oh, I love the little profile picture character, like that, like VTuber thing. I hope you figured it out. Lecty? I like that. I don't know, solving previous year's exams? That's a good idea, I think. Yeah. But you should do it, why not both? You should study chapters, and I would say you should still study the chapter first and then use previous exams as additional homework problems, as additional practice. There's like learning the theory, which you don't want to skip. If you're just reading solutions and working problems, you're going to get into a pattern matching approach. Karsdaro. I mean, pattern matching isn't wrong. AI is pattern matching. Like, talking about ChatGPT and Gemini and Claude, what they're doing is they're doing pattern matching, and it's tremendously good at pattern matching. But it's not real true understanding. But you might get a good grade if you're just pattern matching. Like, that is a common approach. It's just not the best if you want to truly learn the material. But if you just want to get a grade, I don't know. Yeah. 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 All right. Well, thanks everybody for watching. I'm pretty wiped, and this runtime is already getting too long. It was a pleasure hanging out and practicing math with everybody today. Tomorrow we will continue with linear algebra, and we're going to get to chapter 4 on determinants. I know that determinants make some people mad, but I like them. We're going to work some determinant problems tomorrow. Check out my new guitar video. Yeah, it makes Axler mad. Yeah, the same way that all the names on my guitar make some guitarists mad, determinants make Axler mad. So yeah, tomorrow we're gonna make Axler mad again by solving some determinants by hand with real numbers, and literally real numbers. And yeah, it should be fun. This is a first course in linear algebra, and I do think it's the right way. You should teach determinants in the first course. Whether or not you teach determinants in the second course, I think he's got an argument. I don't know. I'm not qualified to say whether or not you should teach determinants in the second course. I look forward to doing a second course in linear algebra without determinants. It sounds really pretty. Sounds really, really elegant, but we're in semester 1 right now. Thanks for watching. Bye. Bye, everyone.